Hey everyone, it's Nikki, and for my extra credit video, I'm going to be solving the Aberrations number 1 problem from tonight's homework, which was a little optics, a little math. So the problem wants us to find the magnitude of separation between the focal length for blue light and the focal length for red light on this double convex lens that's going to be made out of crown glass. So here I have the indices of refraction for the blue light and the index of refraction for the red light. Here I've drawn sort of a little diagram of what that lens would look like and included the radius of curvature for each side. So for R2, you can see that the center of the circle is, for R1, the center of the circle is positive, so therefore the radius of curvature is positive, and then for the other side, R2, the center of the circle is negative, so the radius of curvature is going to be negative. That's how I remember it in my head. So the equation that we're going to be using for this problem is the lens maker's formula, which looks something like this. So you have these indices of refraction over times 1 over the radii of your curvature. And for this problem, I'm just going to use a simplified version of this equation that you can do when the medium is air, which it is for this problem. So these both equal 1. And so I'm just going to write it like this to make it a little easier. 1 over R1 minus 1 over R2. So let's do it for blue light first. So I'm just going to go ahead and plug in some numbers. 1 over F equals this 1.5293 minus 1 times 1 over 0.06. I'm going to go ahead and put these in meters just to make it easier. And because you're subtracting a negative number, I'm going to make this a plus sign. And so, just based on my notes, I already did some of these calculations. This actually equals something like 33.33, and then I'm going to multiply that by the difference between 1.5293 minus 1. So that equals something like 1 over 17.64. So the focal length of the blue light equals 0.056689. And I'm keeping a lot of decimal places because the answer wants to have 2 decimal places in the answer. So I want to make sure that I have enough when I get to the end. And then I'm going to do red light next. So just the same thing. 1 over the focal length equals the index of refraction, so 1.5204 minus 1 times these same radii. So again, this equals 33.33 times the difference between those two numbers. So that equals something pretty similar to the top one. So the focal length of the red light is 0.057670. And it probably actually isn't correct to say something like the focal length of the red light, but because they're different wavelengths and they're going through the same lens, they're going to have different focal lengths. That's the way I interpret that. I hope that's right. Now, we're just going to finish up the problem. I'm going to find the difference between these two focal lengths. And let's just see. I brought my calculator over here, so let's try it out. 0.057670 minus 0.056689, and that equals 0.000981 meters. And that's the difference between those two focal lengths. And the answer is in millimeters online, so I'm going to go ahead and convert this to millimeters. So there are 1,000 millimeters per 1 meter. So this times 1,000 would be 0.981 millimeters. And that's your answer.